This is question 23 from January 2022, paper 1 HR, and the question says, two particles P and Q move along the straight line. The fixed point O, it lies on this line. Displacement of P from O time T is S meters. So this is for P, and this is the displacement equation for Q in terms of it's X, and here this is S. This is displacement. So find the range of values of which T is greater than 1, which both particles are moving the same direction along the straight line. So they're moving in the same direction, meaning that either we have VP and VQ moving to the right, or VP and VQ moving to the left. If they both move to the right, it's going to be a positive velocity, V, and if they both move to the left, it's going to be the negative velocity. And positive velocity means that T is greater than 0. And negative velocity means that T is less than 0. So we're going to solve for the both cases, and the equation or the inequality we get at the end is going to be our answer. So let's find out for the T greater than 0 first. I have for P, I'm going to do the displacement, the differentiation. Why I thought even about the velocity is because it's moving. I can't use distance or displacement. I need to change these by differentiation to change them into V velocity. From D to V, the equation undergoes differentiation. So T cubic is going to be 3T squared minus 8T plus 5 greater than 0. So then I'm going to solve it as a regular inequality. I'm going to put it on the calculator. So 3 minus 8, 5, then it's going to be T equal to T, what's going on? T equal to 1, and T equal to 5/3. So don't forget the brackets. I'm going to write them in opposite signs. So T is 3T minus 5. So I have greater than 0, so I'm going to write them as separate. So T 1 and 5/3 is going to be T less than 1 and T and 5/3 and T greater than 5/3. Then this is the first for P. We're solving for positive velocity for P. Now positive velocity for Q. V for Q. I have differentiation is going to be 2T minus 4 greater than 0. It's going to be 2T greater than 4. I move the negative 4 to be plus to the other side. Then T is greater than 4/2. T is greater than 2. So to find out which single inequality satisfy these two cases or these three inequalities, I'm going to draw a number line. I have here 0. I have here 1. I have here 5/3. I have 2. I'm going to arrange them. Then I need T greater than 1. So T greater than 1. going to be like this. This part is shaded. T less than 5/3. I have 5/3 and here. So I'm going to shade this part. Then t is greater than 2. I'm going to shade this part. So each part we have the common shading. I have here 2 common shadings. However, this part is smaller than this part. So here is going to be t greater than 2. Since this part was a small shading, it didn't complete. Like the 5/3 is going to move like this, and only like a small part is shaded. Not as they move both together, they're going to be also like connected, or sorry, be shaded on the same or under the same line. So I have, now the second is for negative velocity, is for t less than 0. For p, I'm basically going to, these are the same steps basically. I'm going to write only the equation. We just squared minus 8t plus 5 less than 0, so it's going to be t, and the small is on the left and the big is on the right. It's 1.6. This is 1.6. 6. Is that alright? And for q, I'm going to write the same inequality, however, flip the inequality sign. So 2t minus 4 less than 0. So 2t, or t is less than 2. So again, find another inequality that satisfy this all. I have t is in between both, so this is shaded. Then t is, or 2 is less, or t is less than 2. So this part is also shaded. It's common. The inequality is going to be, for this part, is 1 less than t, and t is greater than, and t less than 5/3. So these are the 2 inequalities satisfying both, or this inequality satisfies both p and q for the positive case, because the question didn't specify whether the velocity is going to be increasing or decreasing. So I wrote the both cases so I can get both marks.